Okay, the screen is visible.
Yes, sir.
Screen is visible. Okay.
Yes,
So,
sir.
good afternoon, everyone. Welcome you all for ND lecture. So, in the previous lecture, we have solved the numerical examples based on the determining the transfer function, driving point function, or we can say the network functions for a given network. So, we have solved almost 5 examples based on that particular point. So, after that, we have solved we have discussed about the poles and zeros. Okay, so poles and zeros we have discussed. After that, so the case 1, case 2, all those points we have discussed. So today we are going to discuss now the next point. For that purpose, I will share the whiteboard here. So we are discussing the poles and zeros. This point, poles and zeros of network function. So in that, we have seen the definition of poles, we have seen the definition of zeros, then how to express the poles and zeros from the mathematical expressions by using mathematical expressions. So n of s is equal to p of s divided by q of s, where p of s is and q of s is these are the polynomials of the s. So numerator, that is p of s is equal to 0. If you are putting, you can get the zeros. If you are putting q of s is equal to 0, then you are getting the poles. Okay, that already we have discussed. So after that, we have discussed about some important points regarding the poles and zeros. Node point also we have covered, and one example also we have taken how to plot the poles and zeros of the given network. So second example we can take here. So n of s is equal to 7 into s plus 1 bracket square, then into s plus 3 is there, so divided by s plus 2 bracket square. So my question is, how many poles are there and how many zeros are there in the given network picture? So meanwhile, I will start to plot the poles and zeros. You can tell how many poles are there and how many zeros are there and at which location they are located. That you can tell me now. So on x-axis, this is a yes domain plane. Yes domain plane or yes domain we can consider. So on x-axis, real part of the complex frequency. Yes is the complex frequency. So that is nothing but sigma. Sigma n you can use. So on a y-axis, imaginary part, that is j omega n. So omega means angular frequency or radian frequency, you can say it. And sigma n is Napier frequency. That already we have discussed in the first point of the complex frequency. So I will plot the 0 here, 1, minus 1, minus 2. This is real part, real axis, minus 3, minus 4. And here it is 1, 2, like this. On y-axis, we can plot the positive value here. So it is 1, it is 2, it is 3. So you can understand that is 1j, 2j, 3j, like this. So these values are omega n. Here it is minus 1, minus 2, minus 3, like this. So how many poles are there? How many zeros are there? Who will tell? So I am talking about first of all poles. So poles is what? Q of S is equal to 0. So Q of S means this pole. S plus 2 bracket square is equal to 0. म्हणजेच काय? S plus 2 into S plus 2 is equal to 0. म्हणजेच काय होणार? S plus 2 is equal to 0 and S plus 2 is equal to 0. So S is equal to minus 2 and S is equal to minus 2. So at minus 2, there are the two poles. So how many poles are there? Multiple poles. So how to plot that poles? How to plot? By using X or 0? Yes? Anyone?
By using X.
Yes. So at location S is equal to minus 2 means real part. So this is here. So at there are the two X you have to plot. So how to plot? See, somewhat you have to show like this. म्हणजे दोन दिसायला पाहिजे तिथं. 2 times X त्याच्यावरतीच गिरवायचं नाही, थोडं स्लाइटली घेऊन तुम्हाला तिथं परत एकदा X किंवा मल्टिप्लिकेशन साइन that you have to put here at the location S is equal to minus 2. इथं दोन दिसत आहेत का बघा, थोडं झूम करून बघा. You will get two poles at S is equal to minus 2. Now next one, you have to plot the zeros. Okay, so zeros you can plot by using what? P of S is equal to 0. 7 is the constant, that is the H. 7 is the H value, that is scale factor, that forget about that. So S plus 1 square into S plus 3 is equal to 0. आता S plus 1 ला 2 आहेत, S plus 3 ला 1 आहे. So S is equal to minus 1 and S is equal to minus 1. Here S is equal to minus 3. So all are the 0 location. So 0 you can plot. 0 you can plot at S is equal to minus 1. आता minus 1 कुठे इथं आहे, इथं 2 0 प्लॉट करायचं म्हणजे एकावरती एक तुम्ही असं काढू शकता. This is 1 0. This is another 0. So 2 zeros you can mention. Okay, at S is equal to minus 1. आता S is equal to minus 3 ला अजून एक 0 आहे. So total 3 zeros are there. So you can show that. So these are nothing but what? Zeros. So these are the zeros. And this is what? This is what? Poles. 2 poles and 3 zeros total. So in this way, you have to plot the poles and zeros. Have you understood now?
Yes, sir.
Okay. So next example I will take. Next example I will take. Now you can help me how to plot the poles and zeros. Okay. So here you can take the third example. So third example, 1 minute. So third we can take. So N of S is equal to S plus 1 square into S plus 5 divided by S plus 2 into S plus 3 plus J2 into S plus 3 minus J2. Okay, so this is the given network function. So how we can start? First of all, I will draw the S domain. So always keep this part longer. Okay, most of the poles and zeros lies in the left hand side. So this is J omega N. This is sigma N. So 0. This is minus 1, minus 2, minus 3, minus 4, minus 5 up to that one. I will take 1, 2, 3. Up to 3 I will take. This is minus 1, minus 2, minus 3. This is 1, this is 2, this is 3. Okay. Now, first of all, we can plot the zeros because it looks like a simple one. Okay. पहिला आपण काय करूया, zeros घेऊया. Zeros. How many zeros are there? हाऊ टू आयडेंटिफाय? एस चे किती घातांक आहे? ओके, 3 असणार आहे. s raised to 2 and s raised to 1 means total 3 zeros will be there, but at what location? That you can find out by using p of s is equal to 0. So p of s means s plus 1 bracket square into s plus 5 is equal to 0, means s is equal to -1, s is equal to -1, as well as s is equal to -5. So these are the zeros location. So according to that, you can plot the zeros here. So zeros I will plot at s is equal to -1. There are the 2 zeros. So this is first zero, and this is the second zero. Okay, at -1. At s is equal to -5. At s is equal to -5. One more
1
zero is
0.
there. That you can plot here. At s is equal to -0. You can plot one more zero. Okay, so total zeros over. Now poles. Poles we have to plot. Poles we have to plot. That is q of s is equal to 0. So s plus 2 into s plus 3 plus j2 bracket complete into s plus 3 minus j2 bracket complete is equal to 0. So total 3 poles will be there. So first pole will be at s is equal to -2. S is equal s plus 2 is equal to 0. Means s is equal to -2. Now it is interesting. So s plus 3 plus j2 is equal to 0. Okay. मग s एक लेफ्ट साइडला ठेवा, बाकीच्या इकडं राईट हँड साइडला जाणार घेऊन. सो दॅट बिकम्स -3 minus j2. s is equal to -3 minus j2. नेक्स्ट वन. सो या लोकेशनला एक पोल्स असणार. नेक्स्ट हा घेतला तुम्ही s plus 3 minus j2 is equal to 0 घेतला, तर s as it is. So this 3 goes to the right hand side becomes -3. This minus j2 goes to the right hand side becomes plus j2. एवढं तर कळतंय का तुम्हाला सगळ्यांना?
Yes, sir.
Okay. Now at s is equal to -2, one pole will be there. That is s is equal to -2, where it is here. So one pole I will mark. Okay, at -2. Now s is equal to -3. कधी पण कॉम्प्लेक्स कॉन्जुगेट पोल्स असतात ना, ते 2 मध्ये असतात, एकच नसतं. तसं कॉम्प्लेक्स कॉन्जुगेट असतात. ऑलवेज रिमेंबर. इथं कसं रिअल पार्टचं एक असू शकतं, पण जेव्हा कॉम्प्लेक्स नंबर येईल, कॉम्प्लेक्स रूट्स येईल, तेव्हा ते कॉन्जुगेटच्या फॉर्मॅटमध्ये असतं. ओके, आता त्यातलं रिअल पार्ट बघायचा. रिअल पार्ट मीन्स दिस वन, दिस इज रिअल पार्ट and this is imaginary part, that you can easily understand. Okay, आता दोन्हीकडे बघा, -3 रिअल पार्ट आहे. सो -3 कुठे आहे? इथे आहे. सो -3 मी असं एक वर्टिकल लाईन काढतो, that you can understand. नेक्स्ट -j2 आणि +j2. सो हा काय +j2 आहे. सो +j2 ला मी असं हॉरिझॉन्टल लाईन काढतो, आणि इथं -j2 हा हॉरिझॉन्टल. आता पोल्स कुठे असणार आहे? इथं असणार आहे, या पॉइंटला आणि या पॉइंटला. म्हणजे रिअल पार्ट आणि इमॅजिनरी पार्ट दोन्ही बघायचे. सो दिस इज अ पोल, दिस इज अनदर पोल. So these are called as what? Complex conjugate poles. These poles are called as what? Complex conjugate poles. So I will give the mark here. Complex conjugate poles. Complex conjugate poles. Okay, so combinedly these two are called as what? Complex conjugate poles, whereas these are the zeros, that you can easily understand. Zeros. So these are the examples we have taken how to plot the poles and zeros of the network function in a yes domain. Everyone understood? Any doubt? Any questions? Yes or no?
No, sir.
No, sir.
Okay,
sir.
everyone understood? So here directly the roots are splitted here. काही वेळेस ते एक्सप्रेशन मध्ये दिलं जातं. ओके, त्यावेळेस तुम्हाला रूट्स फाइंड आउट करावं लागतील अशा फॉर्मॅट मध्ये. सो वी आर गोइंग टू सॉल्व सच एक्झाम्पल्स इन द टाइम डोमेन बिहेवियर. At that time I will teach you, okay, how to split. So time being, how to plot the poles at 0, that we have to discuss and that we have to understand. So here, which part is left hand side here in S domain? This is the total S domain. बरोबर है? This is called as S domain. S means frequency domain. So here, this part is LHS, left hand side. This part is RHS. ओके, हा जो इमेजिनरी ऍक्सिस आहे ना, इमेजिनरी ऍक्सिसच्या लेफ्ट साइडला, तुमच्या लेफ्ट साइडला लेफ्ट हँड साइड LHS आणि इकडे काय असणार आहे, राईट हँड साइड. जर पोल्स हे लेफ्ट हँड, पोल्स अँड झिरोज जर लेफ्ट हँड साइडला असतील तर सिस्टम स्टेबल असतं. व्हॉट डू यू मीन बाय? आय एम टेलिंग, if the poles and zeros, especially poles, are lying in the left hand side of the S domain, then the given system is stable. If the poles are lying on left hand side as well or on the y axis किंवा on the imaginary axis वरती जर पोल्स आले तर सिस्टम काय असतं, मार्जिनली स्टेबल, म्हणजे पूर्ण नसतं, अंशतः. ओके, आणि जर पोल्स जर राईट हँड साइडला आले, if poles are lying in the right hand side, then we can say that the given system is unstable. So these are the prediction of whether the system is stable, marginally stable or unstable. So that point is called as what? Stability of the system. So that we can find out by using the poles and zeros of a given network function for that particular system. Okay, so we can discuss now the stability of the system. Actually, Routh criteria was there in the previous syllabus, that was removed here because that part is added in the control system subject, already present it is. So that's why that part, that point is removed from the syllabus of NTA. So based on the polynomial of the network function, we can find out the stability by using Routh-Hurwitz criteria. So that point is removed. Okay, but based on the pole zero plot also, we can determine the stability of the given system. So we can take the next point, stability of the system based on pole zero, based on pole zero plot, based on pole zero plot. Okay, so that point we can discuss here. So first point, stable. So when the given system is stable, the network function of given system, network function of given system is said to be stable, when all poles, एक पण पोल इकडे राईट हँड साइडला किंवा इमेजिनरी ऍक्सिस वरती दिसता कामा नये, when all poles lies in the left hand side किंवा LHS आपण म्हणू शकतो, left hand side, in bracket I will write LHS, left hand side of S domain. S domain, you can write it. So second one, marginally stable. Marginally stable. So if poles are located, on imaginary axis, then the network function of given system, is said to be marginal stable. is said to be marginally stable. Marginally stable. So last point, unstable. So exactly opposite to first point. The network function of given system, network function of given system is said to be unstable. It's said to be unstable when poles lies in एक जरी पोल जरी राइट हँड साइडला आलं तर सिस्टीम अनस्टेबल. When poles lies in the right hand side of S plane. Right hand side of, that is RHS, right hand side of S plane. So these are the important conclusion from the poles and zeros plot we can get. So whether system, or we can predict whether the given system is stable, marginally stable, or unstable. Okay, so first of all, what we have to do for the given system, we have to get, we should know the transfer function, we should know the driving function or network function. So from that we can plot the poles and zeros in S domain, and from the poles and zeros plotting we can find out whether the given system is stable, marginally stable, or unstable. So this is what the procedure or application of poles and zero plot. Okay, so that is this part is very important in the control system part. So this concept we require. So next we can discuss the significance of poles and zeros of the network function. If anyone having any questions related to this point, you can ask. Any questions? Yes, anyone? Roll number 6, A division, Shilpa. Roll number 6 is there?
Yes, sir.
Yes, sir. Any questions, Shilpa?
No, sir.
Roll number 16, Pradnya. Roll number 16.
Yes, sir.
Any doubt, any questions? Okay. Roll number 35, Ayesha.
Yes, sir.
Any questions?
No, sir.
From B division. Om Gauli, roll number 45. Any questions, Om?
No, sir.
Okay. Swarali Joshi, roll number 8.
Yes, sir.
Questions? Any questions from this point?
No, sir. No, sir.
Okay. So, we can discuss the next important point, because that point was asked number of times in the university question paper for 4 marks. So what is that point? Explain the significance of poles and zeros of the network function. So at least they are expecting, examiners are expecting to write the 4 significance, because if the question was asked for 4 marks, so at least they are expecting 4 points. Okay, so we have total 6 points. So out of that, you have to write at least 4 in the examination. So based on that, in the upcoming examination, they may ask the MCQ questions. So this point, you can make it the important point from this chapter. So that heading will be the significance. Significance of poles and zeros. Poles and zeros of network function. So there are the 6 points we can discuss one by one. All are the theoretical points, but it will give a lot of information regarding the poles and zeros. So first point will be the definition. Definition of what? Poles and zeros. So mathematical point of view, we can define it. Okay, definitions. So first of all, I will consider the poles. So what is the definition of pole? Mathematical point of view, you can tell. I have used number of times that word. The denominator polynomial q of s is equal to 0. If you're taking, you will get the poles. Okay, so poles are defined as, it is defined as pole mana fakta pole, it is defined as the roots of denominator polynomial q of s equal to 0, okay, of network function n of s, of network function n of s, full stop. Pole is defined as the roots of denominator polynomial q of s is equal to 0 of given network function n of s. So how to represent? It is represented by, or it is denoted by x किंवा cross. It is denoted by x. Okay. Next, zero. Definition of zero. So it is defined as, only you have to replace p of s. q of s ची जागी p of s. Numerator polynomial. So it is defined as the roots of numerator polynomial p of s is equal to 0 of network function n of s. Okay, so it is denoted by circle or 0. It is denoted by this circle or 0, we can say. Okay, so this is what the definition. First point, everyone understood? Yes or no?
Yes, sir.
Okay, so first significance over. Now next, amount. Okay, so amount or count we can see. So what is that? Point 1, amount, the number of poles are always greater than or equal to number of zeros of the given network function. Similarly, the number of zeros or the number of poles are greater than or equal to number of zeros, or the number of zeros are less than or equal to number of poles. Like this, anyone you can use it. दोन्हीपैकी कुठला पण एक यूज करू शकता. That is the second significance. So any questions related to these two significance? Okay, so next, third one, that is the output of network function. Output of network function. So what is the output here? Output n of s. पोल्स कधी काढता येतो आपल्याला? पोल्स कधी काढता येतो? जेव्हा डिनॉमिनेटर पॉलिनॉमियल q of s 0 असतो. मग डिनॉमिनेटर पॉलिनॉमियल जर 0 असेल तर n of s काय असतो? I will write here, n of s is equal to P of S divided by Q of S. मला सांगा Q of S जर आपण 0 केलं तर N of S चं व्हॅल्यू काय होतं?
Infinity.
Yes. So N of S, when we are putting infinity, then and then we are getting the poles, no output. So we can write like this. The poles of network function, the poles of network function determines the poles of network function determines the output has reached the infinite value. The poles underline of the network function determines the output has reached at infinite value. That is, N of S becomes infinite when Q of S is equal to 0. Okay. Similarly, the zeros of network function determines the output has reached. काय येणार आता? What will come? Yes, output has reached at 0 value.
0.
At 0 value. That is, N of S is equal to 0. It is possible when P of S is equal to 0. Okay, this is the third significance about the output. Now fourth, addition of poles and zeros. Poles and zero add केलं तर काय होईल? Addition of poles and zeros. What will happen if I will add the poles and zeros? Poles and zeros मी सांगितलं होतं RC network. So what will happen? So that we can discuss. Addition of poles. All those things you can learn in the control system. Okay. Addition of poles will delay the response of the system. Poles add केला तर response थोडा delay होईल. म्हणजे इनपुट आणि आउटपुट मधला जो टाइम असतो त्याला थोडा वेळ लागेल. Okay. Addition of poles will delay the response of the system, but it will convert the unstable system into stable system. That is the advantage. Next, addition of zeros. Addition of zeros, what it will give? It will increases. Addition of zero, it will increases the speed of the system. Zeros add केल्यामुळे काय होणार आहे? सिस्टमची स्पीड वाढणार आहे आणि पोल्स ऍड केल्यामुळे डिले वाढणार आहे. ओके, बट पोल्स ऍडव्हान्टेज काय? इफ पोल्स वी आर ऍडिंग द अनस्टेबल सिस्टम वी कॅन कन्वर्ट इनटू स्टेबल सिस्टम. Next, these are the 4 points we have discussed. If any questions will be there, you can ask. Okay. So 5th point we can discuss. So 5th point, continue. Stability of the system already we have discussed, but that we have to write in the significance. Stability of the system we can find out, no, from the poles and zeros. So that we can add, that we have to write. A point. What will be the stability condition? Stability असण्यासाठी काय पाहिजे? पहिला condition. 2 conditions will be there. Number of poles should be greater than or equal to number of zeros. That is the first condition. And second condition is what? All poles lies in the left hand side of or LHS of S domain. सगळे poles left hand side ला पाहिजे. No single pole should be on imaginary axis as well as in the right hand side. Okay, so that will be the condition for determining the stability of the given system. So 6th point. So 6th point is what? the poles and zeros provides useful information of the network function. मग युजफुल इन्फॉर्मेशन म्हणजे काय? एक्झाम्पल, टाइम डोमेन बिहेवियर. Time domain behavior we can find out from the pole zero plot. So that point is there in our syllabus. So we have to solve the numerical examples based on the time domain behavior. We have to find out the time domain behavior from the given network function using pole zero plot. Okay, that is a big topic, we have to discuss it. So these are the some points. Poles and zeros provide the useful. So in that, under the 6th point, we can discuss some sub points here. So first of all, we can discuss about the driving point function. जर समजा नेटवर्क फंक्शन हे ड्रायव्हिंग पॉइंट फंक्शन असेल, तर त्याच्यावरनं तुम्हाला काय युजफुल इन्फॉर्मेशन मिळेल, that we can discuss now. So driving point function always depend as z of s or y of s. Okay, driving point impedance, driving point admittance. So z of s, if you are taking z of s is equal to v of s divided by I of s. Okay, मग मला सांगा z of s जर मी सांगितलं, z of s म्हणजे काय? इम्पेडन्स. इम्पेडन्स इन्फायनाइट कधी होतो किंवा ओपन कधी होतो?
When I equal to 0.
Yes. So a pole of z of s has zero current. म्हणजे करंट जेव्हा 0 असेल तेव्हाच ओपन सर्किट होणार, म्हणजे z of s इन्फायनाइट होणार. Okay, so that point we can write here. When I of s is equal to 0, then z of s becomes infinite, that is open circuit. When v of s is equal to 0, at that time z of s becomes what? Short, that is 0, that is short circuit. So similarly we can write about the y of s. Okay, म्हणजे आता नेटवर्क फंक्शन आपल्याला डिफाइन करता येतं आय च्या व्हॅल्यू वरनं. ओके, ड्रायव्हिंग पॉइंट फंक्शन वरून. सो दॅट विल गिव्ह द इम्पॉर्टंट पॉइंट. मग ह्याचा जर तुम्ही प्लॉट काढला, झेड ऑफ एस जर तुम्ही प्लॉट केला, सपोज दिस इज द झेड ऑफ एस, सिग्मा एन ओमेगा एन जे ओमेगा एन. झिरोज कुठं असणार आहे? इथं. आणि पोल्स कुठं असणार आहे? इन्फायनाइटला. ओके, so poles will be at this location. So this will give the information regarding the poles and zeros of z of s. Maximum pole कुठे येऊ शकतं? तर इन्फायनाइटला. आणि मॅक्झिमम पोल झिरो कुठे येऊ शकतं? झिरोजला. ओके, so next the time domain already we have discussed, that will be find out by using the poles and zeros. So similarly driving point admittance you can find out. इथे मी ड्रायव्हिंग पॉइंट फंक्शन घेतले, त्यात इम्पेडन्स घेतलंय, तुम्ही त्याच्यावरनं ऍडमिटन्सचं पण काढू शकता. So this is about what the significance of poles and zeros of the network functions. So if any questions will be there, you can ask. Otherwise, we can take the next points. So next are the some theoretical points are there. So that can ask in the MCQ now, upcoming MCQ in the examination. So all the theoretical part that we can discuss. We have still 10 minutes. We can complete it, because so that we can start the next point in the next lecture, that is the time domain behavior. So necessary conditions for driving functions. Necessary conditions for ड्रायव्हिंग पॉइंट फंक्शन्स. आता आपण दोन पॉइंट करूया, एक ड्रायव्हिंग पॉइंट फंक्शन आणि दुसरा ट्रान्सफर फंक्शन. नेटवर्क फंक्शनचे दोन टाइप्स आहेत ना, ड्रायव्हिंग पॉइंट फंक्शन आणि ट्रान्सफर फंक्शन. त्यातलं ड्रायव्हिंग पॉइंट फंक्शनचे नेसेसरी कंडिशन्स काय असायला पाहिजे, सो दॅट वी कॅन डिस्कस हिअर. सो ऑल आर दी थिअरॉटिकल. बाय रीडिंग ओनली यू कॅन easily understand. So that's why I will take it fast. The coefficients in the polynomial, the coefficients in the polynomials P of S and Q of S of network function, the coefficients in the polynomials P of S and Q of S of network function N of S must be real and positive. त्यांचं coefficients काय पाहिजे? Must be real and positive for driving function. Always remember. अशा टाइपचे क्वेश्चन्स ते एमसीक्यू फॉर्मॅट मध्ये विचारू शकतात. म्हणजे इथं द कोएफिशियंट्स इन द पॉलिनॉमियल ऑफ नेटवर्क फंक्शन किंवा ड्रायव्हिंग पॉइंट फंक्शन मस्ट बी डॅश डॅश अँड दे विल गिव्ह द ऑप्शन्स रिअल अँड पॉझिटिव्ह, रिअल अँड कॉम्प्लेक्स, रिअल अँड निगेटिव्ह असे क्वेश्चन्स ते असे ऑप्शन्स ते देऊ शकतात. नेक्स्ट कॉम्प्लेक्स पोल्स अँड झिरोज असतील तर कॉम्प्लेक्स पोल्स अँड झिरोज must occurs in conjugate pairs. म्हणजे एकच कॉम्प्लेक्स पोल नसतो कधी, त्याचे कॉन्जुगेट मध्येच असतात. ऑलरेडी वी हॅव सीन द एक्झाम्पल. मस्ट occurs in a conjugate pairs. Okay, already we have seen that. There is no need to discuss that point. Already we have taken the one example in the plotting of poles and zeros. Next, the real part of the poles and zero must be zero or negative. The real part of poles and zero must be zero or negative. म्हणजे एक्झाम्पल सांगतो तुम्हाला. एस इज इक्वल टू समजा हा पोल्स किंवा झिरो काही असेल ते. ओके, रिअल पार्ट म्हणजे झिरो असं तर असू शकतं किंवा एस इज इक्वल टू -1 लाईक दिस. एक तर झिरो असायला पाहिजे किंवा मायनस मध्ये असायला पाहिजे, दॅट इज निगेटिव्ह मध्ये. ओके, कोणाचा? ड्रायव्हिंग पॉइंट फंक्शनचा. नेक्स्ट फोर्थ पॉइंट, the polynomial P of S and Q of S may not have any missing terms, between highest and lowest degree of S. Highest and lowest degree of S, unless all even or all odd terms are missing. हे जरा पॉइंट्स समजवतो तुम्हाला मी by taking the example. The polynomial P of S and Q of S may not have any missing terms between highest and lowest degree of S unless all even terms or all odd terms are missing. So example काय असायला पाहिजे बघा. आता मी एक एक्झाम्पल घेतो. s² + 2s + 1 ह्याच्यात कुठलं मिसिंग टर्म आहे का? पहिला बघा, हायेस्ट टर्म काय? s². इथं s⁻1 आहे आणि इथं काय नसतं म्हणजे काय असतं? s⁻0 असतं. ओके, सो 2 इज देअर, 1 इज देअर, 0 इज देअर. देर इज नो मिसिंग टर्म. बरोबर आहे. हे Q of S असू शकतो किंवा P of S असू शकतो. दॅट इज ऍप्लिकेबल फॉर बोथ. सो देर इज शुड नॉट बी एनी मिसिंग टर्म. दिस इज करेक्ट. नेक्स्ट एक्झाम्पल घेऊया. s³ + 2s² + 3s + 1. इथं मिसिंग आहे का? नाही. 3 आहे, 2 आहे, 1 आहे आणि 0. दॅट इज ऑल्सो ओके. नाउ नेक्स्ट, तर असं असेल s³ + 3s + 1. So any missing is there?
Yes, square.
Yes. So square term is missing means this is not a driving function then. This is not a driving function. Okay. आता नेक्स्ट एक्झाम्पल, तर असं असेल s³ + 3s असं जर असेल तर any missing term is there?
s².
s² is there. s⁻0 पण नाही आहे ना.
Yes.
S square is not there. S raised to 0 is also not there. मग हे काय आहेत? 3 आणि इथं 1 आहे. Both are what? Even or odd?
Odd.
Odd. Odd present आहे. Even absent आहे. Okay,
Yes.
इथं काय बघा? Except किंवा unless all even or all odd terms are missing. म्हणजे ह्या दोन एक्झाम्पल वरनं हे करेक्ट आहे. दिस इज करेक्ट वन. दिस इज करेक्ट ड्रायव्हिंग. वाय? कारण वरच्या एक्झाम्पल मध्ये इवन आणि ऑड दोन्ही प्रेझेंट आहेत पण मिसिंग आहे, त्यामुळं तो ड्रायव्हिंग फंक्शन होऊ शकत नाही. पण इथं खालच्या एक्झाम्पल मध्ये इवन टर्म्स मिसिंग आहेत. सगळे इवन टर्म्स मिसिंग आहेत. इवन टर्म्स आर मिसिंग. Even terms missing, so that is acceptable. Only odd are present, so that is acceptable for driving function. Have you understood now the meaning of this last statement here? Unless all even or all odd terms are missing here. So this is what the fourth point. Now fifth point, the degree of P of S and Q of S may differ by 0 or 1. त्याच्यापेक्षा जास्त डिफरन्स असता कामा नाही. सो एक्झाम्पल वी कॅन टेक n of s is equal to असा असेल s cube plus 3s plus 2 आणि खालचा असेल s square plus 4s plus 1. सो हायेस्ट डिग्री किती आहे न्यूमरेटरचा म्हणजे पोल्सचा झिरोचा?
3.
3. आणि खालचं किती आहे हायेस्ट डिग्री?
2.
2,
दोन्ही मधला हायेस्ट डिग्रीचा डिफरन्स किती आहे?
1.
1,
1. So that is acceptable here. This is acceptable because difference is maximum 1. कारण इथे काय म्हणले दोन्ही मधला डिफरन्स P of S आणि Q of S यांच्या डिग्री मधला डिफरन्स जास्तीत जास्त 1 असायला पाहिजे, 0 किंवा 1. ओके, जर असा असेल n of s is equal to s cube plus 3s plus 2 divided by s plus 1 असं जर असेल तर डिफरन्स किती झाला? इथं 3 आहे आणि इथं 1 आहे.
2,
डिफरन्स 2 झाला म्हणजे हा येणार नाही. सो दिस विल नॉट कम. ओके, सो डिफरन्स इज 2 here and difference is 1 here. So first one is accepted. So this is the fifth point and last point of these under the necessary conditions for driving point. The lowest degree in P of S and Q of S may be differ by 1. May be differ by 1 at most. म्हणजे मॅक्झिमम एक डिफरन्स असायला पाहिजे लोएस्ट. म्हणजे आता लोएस्ट म्हणजे काय? इथं s रेस टू 0 आहे याचा लोएस्ट, इथं s रेस टू 0 आहे म्हणजे दोन्हीचा डिफरन्स 0च आहे. इथं दोन्ही केस मध्ये आपण सेम एक्झाम्पल घेतले. म्हणजे सो लोएस्ट डिग्री ऑल्सो यू हॅव टू चेक. त्यांच्या डिग्री मधलं अंतर किती पाहिजे? मॅक्झिमम 1 पाहिजे. सो दीज आर दी 6 different necessary conditions for driving point function. So in the next lecture we can discuss the necessary conditions for transfer function. त्याच्यात पण 6-7 पॉइंट आहेत. त्याच्यानंतर मग आपण टाइम डोमेन बिहेवियर चालू करणार आहे. सो डोंट मिस द टाइम डोमेन बिहेवियर. That point is important. So any questions from your side? Yes or no? Okay. So we can stop here. Thank you everyone.